All right, here we're looking at section 9.3. And in this section, we're going to evaluate trig functions of any angle, and then we're going to find and use reference angles to evaluate trig functions. We're also going to be using the unit circle to help us with both of these. So the first thing, here's my general definitions of trig functions. So I have an angle in standard position, right? Remember, standard position means one of its rays is along the x-axis, and x comma y is a point where the terminal side intersects the circle. X squared plus y squared equals r squared, right? So r is that distance and xy is that point. So here are my 6 trig functions, right? Sine is going to be y over r, cosine is x over r, and here's what we're looking at, right? So these are something you're going to need to know. And in just a few slides, we're going to look at a unit circle that's really going to help put these into, help kind of put these in your brain and help make sense with them. These are also called circular functions. So the first thing we're looking at is -4, 3 is a point on the terminal side of an angle theta in standard position, right? So here's my angle theta. Evaluate the 6 trig functions of theta. So using the information from that last page, I see my r, and I have my -4, and I have my 3. Well, can I find the length of this r using the information that I have? I sure can, because I know that this length is going to be 4 and this length is 3. So now I just have a right triangle so I can find the length of r. So I do that first. So I plug in my information and I find that r is 5. So now I have an x, I have a y, and an r. So now I can find all of my 6 trig functions. So I know that sine is y over r. I know that cosine is x over r. And remember, this negative goes with the x. So some of my values will be negative. My tangent is a -3/4. Here's my cosecant, r over y. Secant is -5 over 4, and cotangent is -4 over 3. Right? It can be really useful to know these first 3, sine, cosine, and tangent, because then just to find cosecant, secant, and cotangent, I just reverse them. Right? These are inverse operations. So my sine is y over r, but cosecant, which is the inverse, is r over y. So I can do that first. So here's the unit circle. So we call the unit circle, and we use this a lot, is where my r is 1. My r value is always going to be 1 for my unit circle. Then I have different x and y values. Okay, so let's look at a real unit circle. Okay, this is a pretty good example of a unit circle, right? And so here are all of the special points that I want to deal with on my unit circle. So these points, these x and y values, are all found from using my special right triangles. Right? Because I learned about 30, 60, 90 triangles and 45, 45, 90 triangles and the special side lengths of those. And that's what helps me find these points on my unit circle. And I know that the cosine in my unit circle is going to be my x value, and the sine is going to be my y value in my unit circle. So this can help us when we're evaluating a lot. Okay, so now I'm going to use my unit circle to evaluate the 6 trig functions of theta equals 270. So I can look at my unit circle and find where my theta is 270, which is right here. So now I know my x is 0, my y is -1, and my r is always going to be 1 in the unit circle. Okay, so I can draw and look what we just looked at my unit circle. So there we go. So now I can evaluate my trig functions. So my sine, of course, is y over r. Cosine is 0. Tangent is undefined because I'm dividing by 0 and I can never divide by 0. So then I can just kind of find my inverse as well by taking the inverse of my fraction. So here are a few for you to try, using our unit circle and also using the core concept that you should have written down. Okay, so now we're looking at some reference angle relationships. So theta is going to be my angle in standard position. So a reference angle is the shortest distance to get to the x-axis. That's how I always think of a reference angles, the shortest distance back to the x-axis. Okay, so I always want to use my unit circle and look at that to help me figure out where am I and how's the fastest way to get back to the x-axis. So you'll see here if my angle is in quadrant 3, the shortest way back to the x-axis is to go backwards against the angle direction that I was going. Okay, so it really does matter where your angle is and what you're doing. Okay, so here I'm asked to find the reference angle theta prime for A when theta is 5 pi over 3. So first I want to do is I want to find 5 pi over 3, and I can use the unit circle that I handed out in class. So find 5 pi over 3, so here's my terminal side. So the distance from that back to my x-axis is going to be pi over 3. So now let's look at a negative 130. Okay, so a negative 130, remember negative degrees go clockwise, is in quadrant 3, so the shortest distance I will be continuing in the negative direction, right? But my angle here is going to be 50 degrees because that's how I can get back to the x-axis. That's the shortest distance to the x-axis. Okay. So here when I'm evaluating, I have to be careful of the signs in each of my quadrants, right? And this kind of depends on my x and my y, of course, because my r is always going to be a positive value, right? Because r is a distance and that's always positive. Okay. So I can use these steps to evaluate my trig function. So I can find my reference angle, then I can evaluate the trig function for that, and then determine the sign based on where that angle's at. Okay, so I want to evaluate the tangent of a negative 240 and then this cosecant of 17 pi over 6. So we can follow those steps, or you can use your unit circle, either way. So first let's follow the steps that were given. Okay, so first I find my angle of a negative 240, which here we go, is coterminal with 120, right? So if I go a negative 240, here we go. So my reference angle is 60 degrees. So the tangent of here is going to be a negative tangent of 60 degrees, which is a negative square root of 3. Okay, so now let's actually look at the unit circle and figure this out using the unit circle. Okay, so I'm looking at a tangent of a negative 240. So here I see the tangent is sine divided by cosine. So if I go a positive 240, I end up right here. So I know if I go a negative 240, I end up right here. Okay, so now I see I have my cosine of negative 1/2 and my sine of square root of 3 over 2. And I know that tangent is sine divided by cosine. So I end up with my sine was square root of 3 over 2. And my cosine was a negative 1/2. So now to simplify this, I multiply both the numerator and the denominator by a negative 2 over 1. So these can cancel out, so this equals a negative square root of 3, which is the same thing I got here. So I can use my unit circle and this information that cosine is my x, sine is my y, and tangent equals sine over cosine to help me figure out exactly what I'm looking at. So let's look at part B using this same unit circle. Okay, so I'm looking for the cosecant of 17 pi over 6. So first thing I want to do is I want to find my 17 pi over 6. Right? Well, and first off, I know that that's going to be more than one rotation because to get all the way around is 12 pi over 6. So I know I have 5 pi over 6 left. So I end up right over here. So I see I have my 5 pi over 6. And I know here that I'm looking for the cosecant. And I know that the cosecant is the inverse of sine. So it's going to be 1 over the sine. So I know I have 1 over the sine of this, right? And sine is my y value, is 1/2. So to simplify this, I multiply by 2 over 1, and I multiply the numerator by 2 over 1, which gives me the value of 2, which is the same thing I'll end up getting down here. Right? This is just much easier for me to think about if I have the unit circle with me, and I can find first the angle that I'm looking at, and then figure out which trig function I'm looking at. Use the values on the unit circle to help you find those exact values, because we always want the exact value. We are not looking for decimals here. So here's kind of a real-world example. So the horizontal distance in feet traveled by a projectile launched at an angle theta with an initial speed v in feet per second is given by this equation. So I've got d equals v squared over 32 sine of 2 theta. So now I'm going to estimate the horizontal distance traveled by a golf ball that is hit at an angle of 50 degrees with an initial speed of 105 feet per second. So I find the pieces of information that I'm given, which my angle theta and my initial velocity, my initial speed. So I can rewrite my model and then plug in the things that I know. So I've got 105 squared over 32 times sine of 2 times 50 degrees. So then I can use my calculator, right, and simplify. Make sure that your calculator is in the correct mode before you do that. And then I find that my golf ball travels a horizontal distance of about 339 feet. So here are a few for you to try. Think about these, especially evaluating these without a calculator. I want you to get very comfortable using your unit circle to help you evaluate these functions. So let's look at our learning targets. First, we were to evaluate trig functions of any angle, and we can always use our unit circle to help us. Then we found and used some reference angles to evaluate those trig functions. So now that we've worked on this lesson and these learning targets, go ahead and work on your homework for 9.3.